Hello P4s! Today we're going to look at direction and translation. First thing we're going to look at is direction. And there are a few directions you're probably aware of. They are forward, backwards, or reverse, sometimes called, turning to the left, so a left turn, turning to the right, so a right turn, and we also have compass directions that we can use as well. So remember, north, south, east, west, northeast, southeast, southwest, and northwest. But for now, we're just going to concentrate on the first four. So we'll come back to the compass afterwards. So, basic directions. Well, I have a little bebop I've made. And if I put him on my board here, on the road, I can think of directions to help him get around. So, for example, forward. If I went forward, 1, 2, 3, 4. So, forward 4. My bebop would end up there, because that is the direction he's facing. So he goes forward in the direction he's facing. So if he was facing that way, you see his little face over here, if he was facing that way, and I said forward 4 times, he would actually go there. If I said forward 4 and then backward 4, he would reverse backwards. So his eyes are still pointing that way, but because he's coming backwards, he's walking backwards to there, because he's backwards 4. Okay, let's have a look at some turns. So I've said right and left turn, so I've kept it simple. But in fact, what they are actually doing is turning by 90 degrees, or a quarter turn is another way of saying it. So here's my little bebop. Imagine he's in a big circle, like a clock. He is turning to the right. So this is clockwise. If he goes this way, so if he turns to the right, it's clockwise. If he turns to the left, it's anti-clockwise. So, here's my lovely clock, or circle. If he turns to point this way, he has done quarter. You know that is quarter of an hour, but it's also a quarter of a turn. And it is 90 degrees. I had him turn right 180, he would have turned all the way round to a half, so a half turn. But we're not going to worry about that for today, because all you need to know is your left turn by 90 degrees and your right turn by 90 degrees. And I'm going to put up on here as well just to help you, and you will have this on Teams as well. Clockwise is going that way, anti-clockwise is going that way. So left is going anti-clockwise, right is going clockwise. So let's get my little Bee-Bot back on the screen. There's my Bee-Bot. I'm going to tell him I want to go over to the corner market here to buy some food. So the first thing I need to do is to tell him to go forward 1. So I'm going to tell him to go forward 1. So forward 1. Then what do I need to do? I need to get over here. I need him to turn. Now, it's very important. He's turning. He isn't going to be moving. He's still going to stay in that square when he turns. He's turning on the spot. So I need him to make a right turn. A right 90-degree turn, or you can say a clockwise 90-degree turn, or a quarter turn clockwise. He's going to turn. So I've just turned him. I've not moved him. I've just turned him. He's just turned right. And now I'm going to tell him to go forward again. 2, 3 spaces. So he's going to go forward 3 times this time. I then need him to turn and face the shop. So he needs to turn that way this time. He needs to turn to the left by 90 degrees. Again, he's not coming out of the square. He's just turning where he is. And then I'm sure you can guess the last move. Forward 1. Tell him to go forward 1. And he's at the corner shop. So you've got questions like this with Bee-Bots, and I would like you to work out the paths to get to the flowers and the treasure. The later questions, if you go on to extra and extension, ask you to use the compass. Instead of saying forwards and backwards, you would say north, south to move the Bee-Bot. Okay, we're now going to consider very quickly how movement can occur if you've got like a grid like this. So for example, here's a little triangle. It could be a Bee-Bot, it could be you. Again, you can give it directions, so you could go forward, just the same. In this case though, I want to show you how you can use compass points. So I could go north 3 and then east 2, and that would mean that the triangle would go 1, 2, 3 north, 1, 2 east, and so would end up over there. Okay. The other reason why I've got the grid out is I'm going to show you what is called translation, which is very similar to what I've just done here with compass points, but this time with coordinates. So here's my triangle. My triangle is currently sitting at 3, 5. However, it ends up over here. This is where it's going to finish. And this is 7, 9. What I need to do is work out what the differences is between, because remember, it goes that way and then you go that way when you do them. So I need to work out what the path is. So you can do it mathematically. So we know our x-axis when we finish is 7, and we started at 3. So 7 take away 3 gives us 4. And then we can work out our y-axis is 9, take away 5 gives us 4. So the amount it's moved is 4, 4. So it's gone along 4 and it's gone up 4. And I can check the grid and see, yes, that's exactly what's happened. The other way to work it out is if you are given the starting point or the end point and you're given how much it's moved. Let me show you. I know my end point is 7, 9. And I have been told that it has moved 2, 3. That's how much it's moved. So I've been told that. So now I need to work out if that's where it finishes and that's how much it's moved or translated, where was it originally? So first thing I do is I do the x-axis. So 7 take away 2. So 7 take away 2. So that gives me 5. 9 take away 3 gives me 6. So my triangle started there before it moved that distance to end up there. So its starting coordinates were 5, 6. Have a go.